Hey everybody, it's Mr. Dan here, and I'm going to give you guys a lesson on redox reactions. This is really for those of you who were unable to come to the conference call earlier today. So let's go for it. Redox reactions, right? Oxidation and reduction. Before we get into this too far, want to review, actually let's turn this sideways here. Let's review some of the rules for assigning oxidation and reduction, oxidation numbers to atoms. This list is shorter than the one that I'd shown you previously. If we were to go look, let's see if I still got it up here. This list here is a little bit more, has a few more details on it. And you can find this in the PowerPoint that I shared with you last week. So we might reference this a few times here, but for now, let's just stick with this list right here. Rule 1 says that atoms in their elemental state are assigned an oxidation number of 0. So, if we look at the periodic table here, hydrogen, just hydrogen on its own is going to be 0. Sodium, all on its own, right? Just a sodium metal is going to be 0. Any one of these, sulfur is going to be 0. It doesn't matter where it is on the periodic table; it's going to be 0. This list is also going to include atoms that are bonded with themselves. Okay, so here's some examples, right? Hydrogen, H2, oxygen. Here, let's zoom in here, right? H2, O2, F2, S8. You can put 8 sulfurs together, right? These are all bonded to themselves. These also will get an oxidation number of 0. Okay? Next one. When we're talking about ionic bonds, monoatomic ions, their charge is their oxidation number is equal to their charge. So something like sodium chloride, NaCl, NaCl, something like that. This is monoatomic ions, meaning we've got one ion here and another ion here. Okay? As opposed to polyatomic ions. Polyatomics would be something like NO3-. We'll take a look at that in just a minute. That would be an example of a polyatomic ion. It's called nitrate. That's different than monoatomic, where we have one sodium ion and one chlorine ion. So their oxidation number is equal to their charge. All right. Next one, a few specific elements get called out here. Fluorine is always going to be -1. That's because it's super electronegative. It's always going to be stealing electrons from other atoms. So it's always going to be -1. Oxygen is the second most electronegative, so it's almost always going to be -2. The one exception is going to be when oxygen is as a peroxide, where you have an O and an H, would be an example. That's where you're going to have it as -1. Okay, and it gives you an example. It gives us some details on that here on this page, right? So here, come on down here. Look at oxygen. It kind of explains it a little bit why. Oxygen is a part of water, H2O, okay? Right? In H2O, oxygen will take one electron from each of the hydrogens, and so that'll give it a -2. And hydrogen will end up as a +1. Okay? Compare that with hydrogen peroxide, H2O2, HOOH. The oxygen can only steal one electron or gain an electron from one of those hydrogens. So it's only going to have a chance to become -1. Hydrogen will still become +1 because it's got that one electron to work with. But between those two hydrogens and the 2 electrons they have, there's also 2 oxygens. So it has to split them up. But most of the time, oxygen is going to be -2, almost always. And then some rules about hydrogen as well. Okay, hydrogen almost always going to be positive 1. Then that's because it's just more likely to lose that electron. It's more likely to lose that. Situations where hydrogen is likely to actually gain an electron are when we have an ionic bonding situation, metal and non-metal. So example for that, maybe we want to consider like something like LiH. Okay, this is a metal and a non-metal, so that's ionic bonding, right? So what's going to happen here is this electron that it's holding, let's see what color I'll give it a black one, right? This one's got 1 electron, and it's going to transfer that to the nonmetal, just like you have in any other situation. It's going to transfer that over, and the hydrogen will then become negatively charged. So you got to just look at the situation, understand how ionic bonding works, understand just like the general rules of where electrons go, and we'll be able to figure this out pretty well. Number 4, the rule number 4 here says that in compounds, right, so whatever the compound may be, whether it's water, hydrogen peroxide, nitrate, sodium chloride, the oxidation number of, or the oxidation state of that compound is going to be equal to, or maybe I'll say that again, the charge of that compound, so whether it be positive, negative, or neutral, that charge is going to be equal to the oxidation number of all the atoms that are present. Okay? So in sodium chloride up here, we've got a positive 1 and a negative 1, right? Na plus, Cl minus. Combine those together, plus 1 minus 1, that's 0. So it's neutral. Okay? The oxidation, sodium has an oxidation number of plus 1. Chlorine has an oxidation number of minus 1. Add those together, you get 0, it's neutral. So that's what rule 4 is saying here. You know, like you guys, this thing about oxidation reduction here, it's almost the same as ionic bonding, right? Like, it's just kind of looking at ionic bonding in a slightly different way. But we can apply oxidation reduction to covalent stuff as well. It's just about where are those electrons assigned to? Where are those valence electrons? Where are they coming from? Where are they going? That's what we're kind of looking at here. So that's why I sent you guys back last week on a refresher course about some of those ionic bonds and stuff. Okay, so here's what I want you guys to do. Given these rules, right? Like, you guys are always going to have these rules with you. It's right here, and there you are at home. You'll always be able to see these rules, or you can see the more complex ones that I gave you in the PowerPoint earlier. You know, you've always got this. We're going to use that to assign oxidation numbers to atoms in compounds, okay, or even just atoms all by themselves. We got to be able to figure out what is the oxidation number when we look at a substance. So, check out number 1. Cl2, right? That's 2 chlorine atoms bonded together. Okay, so what's that going to look like? 2 Cl's. That's going to be Cl-Cl. And if you want to put in the valence electrons, that's pretty small. Valence electrons there. 1, 2, 3, 4, 5, 6. 1, 2. Right there it is. That's what chlorine looks like. This is 2 nonmetals bonded together, so there's no electron transfer going on. It's covalent. So each chlorine has 7 valence electrons without any electron transfer. These guys are going to be using rule 1 to identify the oxidation number, right? These are atoms, and their elemental state are assigned an oxidation number of 0. It's because there's no electrons moving around. So for this one, it's just going to be 0. Let's see. I'm going to zoom in here. 0. Both chlorines get a 0. Both of them get a 0. This is not about the chlorine molecule. It's about the 2 chlorines that are present. Okay? So maybe more accurately, I'd put a 0 here and a 0 here. All right, next one. Let's look at this GeO2. Okay, that's germanium oxide, germanium dioxide. So when looking at this one, we want to ask ourselves some questions. Like, really, one question, like, what do we know about this? Is there anything in my compound that has a special rule written about it? So for this one, germanium dioxide, yeah, you bet there's a rule written about it. Oxygen, it says, where is it? Oxygen is usually assigned a -2 oxidation number, except for when it's a peroxide, which is not the case right now, right? So oxygen is usually -2. Let's write this thing out here. Okay, oops, get rid of that. Okay, so this is GeO2. GeO2. Okay. Oxygen always gets, or almost always gets, a -2. Keep in mind that there are 2 oxygens present here. So we got to have both of those on there. Total here is going to be, okay, good. Go away. Go away. Good. Total here is going to be -4, right? So that's kind of save that for later. But each oxygen gets an oxidation number of -2. Okay? We want to know the total because we need to figure out what it is for the germanium. If you go back to the rules, Rule 4 says that in compounds, all other atoms are assigned an oxidation number so that the sum of oxidation numbers on all atoms in the species equals the charge of the species, right? So the species here is this GeO2, okay? This is a neutral compound. I know that because there's no plus or minus written next to it. So that means then that we can write a little math, let's write a little math problem about this here, okay? We'll write it like this, right? Whatever GE is, that's just gonna be like blank, okay, plus, can I get that color back I had before? Okay. How do I get that to plus -4, okay, equals, and I'll go back with 0 here. 0, okay? Whatever this GE is, plus the oxygen, which has a total of -4, that's going to be 0. So it's pretty easy, right? Like can we just write that in there? Okay, so that's going to be 4. Okay, so GE, that's going to be plus 4. Let's do another one. Calcium nitrate. So this one's a little bit bigger, a little bit tougher. We'll write it out here. Okay. Oops. All right, so we've got Ca. That looks ugly. CaNO3 All right. So how to solve this? Let's go up to our rules and see if there's anything that we know about this that we can use. But we've got calcium, nitrogen, and oxygen. It's already highlighted yellow. Oxygen is usually assigned 2 minus oxidation number. Okay? So something I'm going to do here, I'm going to set this NO3 over here to the side. Like, let's kind of like separate this, right? NO3. Now, if you remember, hopefully this is recognizable to you. This is called nitrate. Okay, nitrate is a polyatomic ion, and it's got a charge of -1. Okay? So, this polyatomic ion with a charge of -1 has 3 oxygens in it. Oxygen has an oxidation number of -2. There's 3 of them. Okay? So that means that it's going to have a total here then of -6. Okay? Over on the other side, nitrogen, right? That one nitrogen plus the 3 oxygens has to equal -6. All right? So let's do let's zoom way in because we can do this, all right? What this got to look like here, this has got to be like nitrogen plus -6 equals -1. So what's that nitrogen going to be? 5, right? 5 plus -6 is equal to 1, or -1. So we can add that in there, and now we know that the nitrogen, it's going to be 5 plus 5. Okay? So now we know what it is for nitrogen, we know what it is for oxygen. Here, let's zoom in here, we'll assign these to the correct place. This is going to be 5, that's going to be -2 plus 5. Okay? So we got to figure out what the calcium is. Well, we're going to use rule 4 again, where the total, like the charge of the thing, right? The charge of the species is the total of all the oxidation numbers. So here, NO3 is -1. But it tells us that we've actually got 2 of them. So this nitrate, or the nitrate side, being that there's 2 of them, there's a 2 negative charge. So we need that to balance out because our calcium nitrate's neutral. So that means then that the calcium's got to be +2. All right, +2 is going to make this whole thing balance out. Another way you could assign the calcium is you could maybe recognize that nitrate is a polyatomic. If you do, then you'd recognize that calcium has got to be an ion too. It's a metal, it's a single metal atom, which puts the calcium alone in that monoatomic ion group. And calcium is also here in group 2. There it is, number 20. And so it's going to have a +2 charge anyways. So you can take that and use that to help you assign the oxidation number for calcium as +2. Okay, let's do another example here. I encourage you to pause the video for a minute and just kind of try this one out on your own before I show it to you, okay? But here we've got, this is phosphoric acid, H3PO4. We want to know the oxidation numbers of hydrogen, the oxidation number of phosphorus, and the oxidation number of oxygen, okay? So I'll write it out here, and then you can go ahead and assign those, right? So what is it for hydrogen? What is it for phosphorus? What is it for oxygen? All right, so pause the video. Use the rules up at the top here and figure out what are the oxidation numbers for each of these 3. Okay, welcome back. Hopefully you're able to figure those out. I'll show you how to do it now. Okay, so using these rules, what do we know? Well, this particular species has two elements that are specifically listed in our rules. Okay, hydrogen, usually +1, and oxygen is usually -2. So let's use that. Let's just see if it works out here, okay? Also notice that this thing is neutral, okay? There's no plus or minus on it, so it's neutral. So we'll just use the rules that we've got and start assigning some numbers here, okay? So hydrogen, it's usually +1. Oxygen, usually -2. So if we put that in here, let's see. How will I show you this here? There's actually 3 of those, right? Oxygens, there's actually 4 of these. So what does that come out to? Well, now we've got +3 and -8, and something here has to add up so that we can have 0 for our neutral species. What's that going to be, you guys? 5? Yeah, it's going to be 5. It's got to be 5. Got to be +5. Okay? So then that means that for this we've got +5. Okay. Take a look at a periodic table. Where is phosphorus? Oops. There it is. It's in group 15, right? 1, 2, 3, 4, 5. So phosphorus has 5 valence electrons. That makes good sense then with our oxidation that goes along with it. All right. I hope you're doing all right. Hope this is making sense. We're just got to use the rules that we're given, go step by step through each one to figure out what those oxidation numbers are. This is about reactions though, guys, and so we're going to change our gear a little bit, and what we want to do instead is start asking about oxidation and reduction reactions. And what I want you to do is I want you to be able to identify what's being oxidized and what's being reduced given a particular reaction. So first step in doing this is going to be figure out what the oxidation states are of the things that are present. Okay, so here's a reaction. Sodium plus bromine is sodium bromide. It's even balanced for you. Okay, so first figure out what the oxidation numbers are for everything that's here, right? So that means you got to find the oxidation number here, and here, and here, and here. That's 4 oxidation numbers that you need to find. Pause the video for a second and do that. Okay, so what are the oxidation numbers for each of these? Use the rules that we've got. Starting with Na, with sodium, rule 1 says that atoms in their elemental state will be 0. So that's going to be 0. Let's put a 0 down. All right, how about the bromine? Well, if you reference back to this one, remember, bromine is bonded with bromine, so that's still going to fit into rule 1. So let's give bromine a 0 as well. Both bromines in that Br2 have an oxidation number of 0. These red numbers are about the atoms, not the compound. All right, So now, the NaBr. Can you recognize what type of compound this is? Hopefully you see that it's ionic. How would you know that it's ionic? Well, here we've got sodium, which is in group 1. That's a metal. And then we've got bromine, which is in group 17. Those are nonmetals. Metals plus nonmetals, right? Metals and nonmetals, those make ionic compounds. So this is going to be ionic. What's the ionic charge of sodium? Coming from group 1, that's going to have a -1 charge, right? So that's going to look like Na plus, and Br from the halogens is going to be Br minus. So guess what? +1, +1, -1. That's what the charges are going to be here. I don't like the way that looks. Let's zoom in here a little bit so we can write it a little cleaner. +1, -1. All right. So there we've got all of our oxidation numbers for the 4 different things that are present here. Now what our goal is to figure out what's being oxidized and what's being reduced. And so here I say, let's go to, those should be capital letters. Oil rig. Do you remember what that means? Oxidation is loss. Reduction is gain. So I'm going to put a little note in here, and I'm going to say, we'll say, of that's not going to fit. We've got to make it look better. Oops. Of electrons. Okay? Oxidation is loss of electrons. Reduction is gain of electrons. Okay? So, pause the video for a second. Look at the sodium. Look at the bromine on the reactant and the product side. Which one is gaining electrons? Which one is losing electrons? Okay, so hopefully what you found out was that sodium is, well, like, let's look at it, right? We have already got Na plus over there. What is sodium doing exactly? Okay, we have Na, and it's got one lone electron, and it's turning into Na plus. Okay, here's why I had you guys do this so long ago. We've also got bromine, and we'll pick, like here, how about dark green. Bromine, Br, and it's got 1, 2, 3, 4, 5, 6, 7 electrons, and it's turning into Br minus. How does this happen? I hope you know, guys. I hope you know. This is coming over here and filling in that spot with an electron. The electron transfer, right? So sodium is losing an electron. Bromine is gaining an electron. So bromine is gaining. Which one is gain? Reduction. Okay, so let's assign some labels over here. Reduction, oxidation. Who's going to go into these? Sodium is losing electrons. Oxidation is loss. Bromine is gaining an electron. Reduction is gain. Get it? Another way you can do this is you can look at how does the oxidation number change. Check out bromine. It's going from 0 to -1. That oxidation number is being reduced. It's going down. So that means then that its oxidation number is being reduced. Okay. This is the last example. I'm not going to work this. I'm going to encourage you to work this out on your own. And then if you want to know what it is, you got to come talk to me. Okay? You got to come talk to me. I'm not going to work this one out. But I'll tell you the steps. Figure out what's the oxidation number for the things that are present. Right? What's the oxidation number here? What's the oxidation number for that oxygen? For the carbon? For those oxygens? What's the oxidation numbers there? And then once you do that, assess how those oxidation numbers change and decide if it's being reduced or oxidized. Okay, so good luck on that. I hope this video tutorial has been helpful for you. I look forward to hearing from you tomorrow. If you have specific questions about anything, check in with me during our morning or afternoon, right? Whether you're grade 10 or grade 11. Check in with our conference call tomorrow. I'll be there at 8:45 or at 12:30 waiting for you, ready to talk. Okay, have a good day. See you later.